And then we can perform simulation and for the time interval of 0 to 10. And these are the return variables where T is the time vector. A should be the stage vector inside the system. And B is the output of the system. Output of the part of the simulated model, not output. We call this output. And this one is the output of the whole system. We use a scope here. We can later display the contents of this scope. So this is the output. And
the output is B.
B.
You name it or just
B should be a vector. Should be a vector. It contains all the information. P1, P2 corresponds to T1, T2. Should be the value of this signal. It's a dynamic signal. However, what I need is to use the final time here. I use the 10. So it should be the last value of this signal. Okay? So D is for the output, and we take the last value from it and use that one as the objective function. So now we can map the original problem into an optimization problem. We can save it. On my band 1, it should be okay. And now we have the objective function already. So now we have to solve the optimization problem like this. X equals to F min search. Then the name of the objective function I use my band 1. This is the objective function. And we can use, and for the initial searching point, we have 3 parameters. We can generate 3 random numbers for the KD, KI, KD parameters. And now we can open the scope here and run the optimization problem. And now you can visualize the control behavior until you can find the optimal controller which give a good control result. But that's interesting. You can visualize it, and finally you find KD, KI, and KD. So this is the application you can use. You can use optimization problem to solve your own problem. Convert it into an optimization problem. And as I have mentioned, we have different kind of control criteria. For instance, the ISE criterion, which corresponds to the H2 norm, which is most used in control. So if you read control literature, you find that most people use this criterion, and it is also H2 norm. And also you may have IAE, which is quite similar to ISE. So let's demonstrate how can we implement this, and what is the result. To solve this problem, the time icon is not needed anymore. So we can easily change the problem into ISE criterion like this. We have E here, E squared, and then integration. So we have changed it to ISE. Use another name. So I did there. So this is a new Simulink model. And what we need now is to change the objective function, because originally I used my model 1, now I have to use my model 1m to get consistent with the Simulink model.
And you need the,
Sorry?
you do need the time, 0 to 10.
So
Yeah.
the time?
Yeah. The
From 0 to 10. Yeah. We will discuss about that later. So just use from 0 to 10. We cannot use infinity. So just use it as 10. Because if we use 10, they already have a good shape of response. So let's see what the ISE criterion or H2 control may get. So we can run the program again. And this, I think this could be the best result for H2 criterion. There's oscillation there, you know. So why there's oscillations? Because it treats the error signal at any time equally. So it doesn't mind whether the error here is large or here is large. It doesn't mind. And they only need to have the integral small. That's the target of ISE criterion. However, with the ITAE criterion, where we use large t, for instance, when t is large, then the weighting here is large. We have to multiply t with the error. So the t, when the weighting function is large, it will force the response to get close, to make the zero, to make the error close to zero as soon as possible. So that's why this ISE criterion, you may get some oscillatory response like this. However, with the use of ITAE, you may have something like this. The initial response is lower, but the steady state are much better. So this is why we want to talk about the ITAE criterion rather than whether you use the ISE criterion. So the question is why they use why there are so many papers on ISE criterion? Because they are very easy to calculate. And the analytical form or closed form solution can be obtained. So since this integral can be evaluated if you do not use the simulation way, you can solve it in the frequency domain method by solving the equation here. E signal E minus S. And you have to take this integral, the H2 infinity, the H2 norm. Or you can solve the Riccati equation to find the H2 norm. So H2 can be solved easily and with standard form or standard routine to solve it. However, ITAE criterion doesn't have any frequency domain form. So we have to solve this kind of problem by the use of computing. When the computers are not very popular, then in old control papers, they usually use the ISE criterion. And now, I think we should use the time weighting criterion instead, because this kind of problem can be solved easily by the use of Simulink and Matlab. So in this way, we can match the original problem into optimization problem and then find the optimal parameters. Now let's consider